So hey everyone, today we are going to discuss the hard problem in today's weekly contest, which is the maximum element sum of a complete subset of indices. Okay, so let's first understand what the question demands. Like firstly, we are given one indexed array, okay, and okay, now we are given definition of the complete. Okay, a set of number is complete if the product of every pair of its element is a perfect square. Like if we are given an array with some elements, the if the product of every pair, like this with this with this with this, if every pair, the product of every pair is a perfect square, then it is called the set is called a complete. Okay, so okay, for subset of the indices, okay, 1 to n represented like this. Okay, how we are defining the element sum. This is the second definition. Like element sum is defined as the sum of all the elements. Okay, like in this set I'm defining the sum of indices as like 1 3 7 9, then nums of 1 plus nums of 3, like 1 3 7 9, like addition of all these are the indices and the addition of all these elements. Like as this is a one based index, so this is defining as the zeroth element. Okay, so we have to return the maximum element sum of the complete subset. Firstly we have to find the subset and then return the subset with the maximum element sum. Okay, so let's dive into the first example and see. Like we are given this array, some elements and we have to find the maximum element sum. Like how are we going to do that? Like for that we have to find the complete sets. Like how are we finding the complete sets? Okay, so it is said that every pair in the sets should be a perfect square. Okay, so how is that? Like this is example. In here we are having 1 comma 4 and 2 comma 8. The size of array is 8, so 1 4 and 2 8. As you see here, 1 4 2 8, 1 into 4 is equals to 4, 2 into 8 is equals to 16 perfect squares. Here in the second example there are 9 elements and given are 1 4 is equals to 4, 2 8 is equals to 16 perfect square again, 4 9 is equals to 36, 1 4 9. Like there are three pairs, like 1 into 4 is equals to 4, 1 into 9 is equals to 9, 4 into 9 is equals to 36. So we have to make a set or we can say a subset which the product of every pair is a perfect square. Like how will we finding that? Okay, so let's say I have an array of size n. Okay, so I have to make a set where every product of every element is a perfect square. How am I going to do that? Let's have an intuition that, like, I'm starting from 1. Okay, and for next elements I have to add elements like that their product with 1 will always be a what I'll say is a perfect square. So what elements will I add? I have 1, like without any intuition, like say 1, I have 1, then I'll say I'll add the square of 2 4, square of 3 9, square of 4 16. Okay, but in case of 1, if I add my first element was 2, what I will add? I cannot add 4 here because 2 into 4 will be 8. Okay, but what I can add is 8 here. Okay, but how am I adding 8? Example, like if I take 2 outside, then that will be 1 4. Okay, that will again be 1 4 9 16, but here it is 2 4 18 32. Like if I take any two elements here, like suppose 2 and 18, how am I going to write that? It is 2 into 18, that is 2 into 1 into 2 into 9, 2 into 2 into 1 into 9. This is a perfect square, this is a perfect square, and 2 is twice, so this is also perfect square. Okay, so how we are going to add the numbers is that Okay, we'll simply say that there are n elements, right? n elements. I have to just focus on the indices of those elements. Okay. Like, what I have to do is I have to create like my, like, this is a sum set. Okay, I have to fix my starting point. Like, if my starting point is 1, is my starting point 2, is my starting point 3, is my starting point 4, is my starting point 5, any number that is my starting point, the rest of all the numbers will be multiplied by that number. If my starting point is 1, the other numbers will be 4, 9, 16. If my starting point is 2, the other numbers will be 8, 18, 32. If my starting number is 3, the other numbers will be 12, 27, and similarly 48 and all. Okay, so you get the basic idea of that. Let's try to code this approach. Okay, so let's calculate the size. So nums dot size. Okay, and my like initial answer is 0. Okay, so for and I is equals to 0, I less than n, I plus plus. Okay. So what I have to like first initialize which number I'm starting with. 1, so this is that. So should be right if I started with 1, is n equals to n. Okay, this is my starting point. Okay, so my nj is equals to 1, while my I into j is less than equals to n. I don't have to store the value anywhere, right? I just have to find the summation of the value. So I do not need to store a vector to contain the value of all these points, like the numbers of 1 plus numbers of 4 plus numbers of 9 plus numbers of 16. I don't have to create a vector for that. I simply can add the value here. So while this is this, I simply add value is plus equals to nums of I times j minus 1. Okay, and my incrementing the j. Okay, so when my I is 1, this will go into that, plus my j is 1, so 1 into 1 into 1 first index, secondly 1 into 2 into 2 fourth index, then 1 into 3 into 3 ninth index, right? When my I is equals to 2, it will go as 2 into 1 into 1 second index, 2 into 2 into 2 8th index, 2 into 3 into 3 18th index. Okay, like what we have written here, like 2 18 3 12 something, right? Okay, so this is it. And okay, now I have to update my answer also. Like my answer is equals to maximum of answer comma the value. Okay, and I simply have to return my answer. Okay, let's read the code again. Initialize the size, setting the answer, and iterating over every element. Okay, and then okay, the one thing that was written here extra was that yeah, in the example, like apart from the subset consisting of single index, okay, the single index subsets, so we will have to handle this also, the single index subsets. How we are going to handle those is like, we'll simply write nj equals to 1 while j into j is less than equals to n. My answer is equals to maximum of answer comma nums of j times j minus 1. Cool. Okay, I'm updating answer here. This is this. Okay, now the output is in long form, so we have to update this as long. Okay, this is of type integer, so we have to specify the type as long. Okay, for entire. Similarly for this one also, it's long. The value should be also of type long and returning the answer. Let's see if this runs. Okay, where we have done something wrong. Wait. Okay, we have update j here. J++. Let's run again. Okay, these test cases are accepted. Let's try to submit this. And okay, that's submitted. Okay, so here's the code, guys. I'll add the code in the description. Please let me know if you have any doubt, and I'll try to explain it in the comment section. Okay, thank you. Bye bye.